Hello, I decided to recreate a blue jammer project, now with a different ESP32, the one without an external antenna, and it will be basically the same. I will start the project with wires, because last time when I soldered everything, the project was not working, not this one but a different project. It also happened to this one, and basically it started and it was doing nothing. I connected an LCD screen and LCD display, and it was starting okay, but then the light was dim and it was not booting fully. So after a few debug sessions, the reason was that the NRF modules weren't getting enough current, because I connected both to 3 volts. So in order to bypass that issue, I then connected both to 5 volts and everything was working. Maybe the wires that I used to solder them on the PCB were too big, I guess. They were 4 millimeters if I'm not mistaken, so maybe they had more resistance, I don't know. Usually these NRF modules are using 3 volts, but in this case switching to 5 volts solves the issue. So let's see. Firstly, I will also share the schematics in the screen a bit later in this video. This should be it, I think. Here should be all the wires needed. And also, if you stay until the end of the video, I will show you something unexpected, or expected, but something that I couldn't explain first time. But it has a reason, of course, now, and I'll explain what's happening at the end of the video. Okay, so everything is connected now, but I can't connect both modules to 3 volts because this ESP32 has only one pin for 3 volts and we have 2 NRF modules. So this is why I'm using a breadboard now in order to connect the 3 volts to both modules. I don't have cables male to female, so that's why I'm trying to convert some. I'm using some paper adhesive to keep them steady, because if you have an imperfect connection, it will not work, or it will fail in the middle of the process. I also decided to add a LCD display. I don't want to be exactly as the last one that I did. It doesn't really make sense. So this version will also have a display. I guess it's easier to choose your target instead of watching the LEDs. So this is the final version. This is the page from MSTA that I followed first time when I did this project, and I found something weird. As you can see here, the first commit on this project was on, let's see, August 2024, right? And everyone knows that this is the main project, but I found this, which is from Smoochy, And it's basically the same project, but the first commit is on March 2024. So the other one was in August. So this is the original developer of the Blue Jammer. I saw that this guy, Smoochie, which was the original developer, has also maintained this project and updated it. You can see here the schematics that I followed. And here is the updated version of his project. In just a second, I think yeah, this one, the Nosy Boy. This is an updated project, but it has an update which doesn't really suit me because it's using a web interface to select your targets, which in my opinion is not needed for this project. I prefer to have physical buttons. You can see here the channel hopping. So yeah, this guy is still maintaining the project. But let's go back to this one, which was copied. And also I saw that this guy copied the web installer, and it's a nice clone after the Space Hunts project, the main original developer of the first Yotter that you can find. So it has a couple of PCBs, models, and basically everything is the same. You see here the flasher, which is one copy from Space Hunt. So yeah, yes, I decided to use the display. We will go with 096 OLED and choose the first one, which is the combo one, which has which will target all the frequencies. I plugged in my module now. You can use this one also for drones. It has a higher range, but I don't want to hope so many channels, so I will go with the combo one. So I will just pair it and click on install. And you have to press the boot button and keep it pressed, because if not, you'll receive this message. So you can go back, you can try again, keep the boot button pressed and try again. Let's see now with the boot button pressed. Clicking install. And now it's working. It shows as stuck, but it's still loading, just the web interface was stacking. So it's still doing the installation. Yeah, as you can see, everything is fine. I don't know why, but when I tried to check the logs here, nothing appeared, but everything works fine. But just didn't have the logs. And as you can see, nothing appears. So at this point I couldn't really check if both NRF modules are connected successfully, but we will be able to check this later in the video. I will try again to check the logs. And it's the same, nothing showing. I resetted the device. It showed on the display that it started again, but logs are not visible. So maybe this is a bug on the web interface, might be, or something was not connected correct. Either way, we'll also add the display, as I said, and also the status LED. So let's check here. Can't really see much because it's a bin file, it's not a INO file. Okay, here you can see the project with the display included. I had to use the ground on the breadboard also because now I had 3 grounds for the 2 NRF modules and the display, and also 3 positive pins for both NRF modules and display one. Let's plug it in, and once the installation is finished, you can see the display message. Here it is. So you can view the selection now on the display. I think it's useful. It's easier to follow the display than the LED. I will also add the LED just because I'm familiar with it now, but it's easier to watch the display. These are some NRFs that I used in a different project, and I soldered them, and I will solder them again onto this PCB. I don't have the best soldering skills, but well, it does the job. As you can see, not great, not terrible. This is the schematics that you can follow, that I also followed. And this is how it looks. Well, it's not beautiful, I can say, but it does the job. This is what it matters. I soldered the display on top just to be easier to be mounted on the case. I will add some tape on the back, not because it's needed, but because I have the holes at the back of the case and I don't want to see the green PCB through it. the usual case that I'm using. Now I shrink it a bit, and it's not so wide there because it was not needed. So it will be not wider, but now it's a little bit thinner than the last one. Since we don't need a lot of space at the back of the PCB. I modified a bit the case so it can keep the display steady, and I'm using some 2mm screws, which I think they are 5 or 6mm long. They won't touch any pins, so don't worry about this. Also modify the buttons. And with 4 2mm screws, everything should stay snug. That's it. Let's see it in action. We will use the antennas which came with the NRFs. As you can see, you can use both the display and the LED. Let's see if it works now, because it's on Wi-Fi. I will share my screen now. And it's not working. This is the part that I told you we will see at the end of the video. We are targeting Wi-Fi, but we still have Wi-Fi. I'm connected on 2.4, but it doesn't jam. So why is that? Because some of the routers are going above 2.4, so they have, I mean it's still 2.4, but they have more channels than other routers, and mine is one of them. As you can see, targeting Wi-Fi, it's still working, but if you will check the list, let's check if we have logs first now. We have both NRFs are successful, so we have logs, and we can check now also what we are targeting in the logs. So this is matching what I'm seeing on the LCD. so there is no issue. But as I said, some routers are using more channels than others. So if you are using the Wi-Fi settings, it might be the case that you are not targeting the channels that some routers are using. To go broader than that, you can use, as I said at the beginning, the other setting that is meant for drones, because drones are using multiple channels, more channels than a Wi-Fi router. So this will capture all the channels available on 2.4. It will hop through all of them. So this means if we are using the setting remote control, which is meant for drones, it should be able to jam to this Wi-Fi also. And as you can see, now it's struggling to connect to YouTube Studio. And now I have nothing. Now it's not connecting at all. So it works, but keep in mind that, as you can see in this list, using the remote control one, which is made for drones, it will go until 2.5 to 5. As for the Wi-Fi, goes to 2483. So just to be safe, use the remote control option and it will target all the possible frequencies, and for sure you will target your desired Wi-Fi. I hope you have enjoyed this video. I hope you've liked this new design of the project. Please subscribe if you are not yet a subscriber, and see you in the next one. Cheers.